Assalamu alaikum. This is case number 2 of the coefficient of friction lecture of engineering mechanics lab. That when the object in the surface is inclined to the x-axis, so how to calculate their coefficient of friction. So this is the object and this is his surface, and when the object is moved on this surface by an applied force along this direction and by a frictional force along this direction, this is the weight of the object and this is the normal force of the object. So let's begin that we have to resolve this into component, because according to this coordinate system, this is x and this is y. So when this is x, this is y, so the only weight is in the coordinate system and all the others are not. So we have to make this on the coordinate system to make them in a resolution. So let's we take like this, that this is the x direction, this is the y direction. Now we can make a resolution of w weight. We can make a component of resolution of weight w. So it's become that this is the weight, this is y direction and this is x direction. So this is the base. So base we become w cos theta, and this is perpendicular, which is opposite to the theta. So this is perpendicular, so we take this w sin theta. So w sin theta is along the negative x-axis and w cos theta is along the downward direction or the negative y-axis. So summation of fx is equal to 0 and summation of fy is equal to 0. Summation of fx mean that summation of all the forces in the x-axis is equal to 0. So p applied force that is in the x direction, and when the force is in the right direction, so we take it positive, and the negative direction we take it negative. When the force is applied upward, so we take it positive, and when it is downward, so we take it negative. So this is positive x-axis, so we take applied force p positive, and friction force, this is the negative x-axis, so we take it negative minus f, and the w sin theta that is also in the negative x-axis, so we take it negative. So rearrange them, p is equal to f plus y sin w sin theta. This is equation number 1. Now summation of fy is equal to 0. It's mean that summation of all the forces along the y-axis is equal to 0. So in the y direction there is a Rn normal force that is along the y-axis, and this normal force is in the upward direction, so we take it's positive, so Rn is positive, and y cos theta that is in downward or in the negative y-axis, so we take it negative, so minus y cos theta. When rearrange them, Rn is equal to w cos theta, rearrange from the equality, so Rn is equal to w cos theta. This is the equation number 2. Now as we saw in coefficient of friction, in a coefficient of friction in a static friction, so we static that coefficient of friction is equal to friction force divided by normal force. So force become coefficient of friction into normal force. So equation number 1 become, this equation number 1 become, we put the value of friction force in equation number 1, so it's become that p is equal to friction force that is mu Rn, so mu Rn plus w sin theta. Put Rn from equation number 2, as from equation number 2 Rn is equal to w cos theta, so we put this w cos theta in the equation number this one. So p is equal to mu Rn become equal to w cos theta plus w sin theta. So it's become that mu is equal to this p in itself, and when this is rearranged So it's become that p minus w sine theta divided by w cos theta, because this w sine theta is in the have a positive value, and w cos theta is in the multiplication with coefficient of friction. So this formula is used for inclined plane when the object is in incline, when the object and surface is in incline to the x-axis. Now if theta is equal to 0 degree, if theta is equal to 0 degree, then coefficient of friction is equal to p minus w sine 0 degree divided by w cos 0 degree. Sine 0 is 0 and cos 0 is 1, so it's become that p minus 0 divided by w into 1, so it's become p minus w. Now we say that this is the applied force and this is the friction force. So when this body is in the static position, so this applied force is equal to this friction force, so p is equal to f. So for this p we can write f. In we saw that w weight is equal to normal force, weight is equal to normal force, so weight is equal to normal force, and for that w we can write Rn, so f divided by Rn. So this make this equation. So when there is an inclined plane, then we can use this equation. When there is not an inclined plane, then we can use this simple equation. So this equation is to find the coefficient of friction. Now when we have to perform an experiment, first of all we have to find the theta of an inclined surface, that how this inclined surface is at some angle. So first of all we find this angle, then we organize weight of different objects like brass or steel. Which object do you have to select? That when we select steel, here is a weight, so the weight is applied over it. This is the applied force, this is the pulley of frictionless pulley, and the weight is applied over it. So this is the applied force, this is the friction force. So we can increase this applied force as when this object start movement, when this object is in the verge position. We saw, as we tell you about the verge position, that what is verge position and limiting friction. So then we can find coefficient of friction according to that formula. So that is our lecture.